In this video, I will be going over some examples of two-step equations to help you with your 100 equations unit. Two-step equations require two steps to isolate the variable when you're solving the equation. Most of the time when you are solving two-step equations, the first step is to add or subtract a constant. And the second step is to multiply or divide by the coefficient of the variable. For your 100 equations unit, there are two tests that have two-step equations. Test 4 and Test 5 each have 10 points, for a total of 20 points. Let's look at some examples of two-step equations that are taken from the actual tests in the 100 equations unit. Remember that the goal of all equations is to isolate the variable, and in these two-step equations, most likely the first step is going to be to add or subtract a constant. So in this first example, the constant is 6, so if I subtract 6 from both sides, I'm left with negative 10x equals 68. The next step is to either multiply or divide by a coefficient. The coefficient of x is negative 10, so if I divide by negative 10, I'm left with x isolated. And when I divide by negative 10 on the right side, I don't get a nice, neat integer, so you can leave it as a fraction as long as you reduce it. This case would be 34 over 5, and it's negative. I would accept that as an answer. You could go a step further and change it to negative 6 4/5 or negative 6.8, but that's not required. So make sure that you reduce it, otherwise it'll be a half point off. For this next example, we are going to try and isolate the variable v, and so the first step will be to take away the constant 9, and when I subtract 9 from both sides, I'm left with v divided by 5 is equal to 2. And you might be able to do this mentally. What number divided by 5 is 2? It's 10. I get that answer by doing the opposite operation, which is multiplying by 5. When I multiply by 5, I am left with v isolated, but I also have to multiply by 5 on the right side, and I get that answer of v equals 10. Moving on to the next problem, we are trying to isolate the variable y, so the first step will be to subtract 64. When I subtract 64, this is where I see a lot of students make their errors because they forget that two negatives together, we're going to add those and make it a negative. So negative 13, take away 64 more is negative 77. And that is equal to 7y. Again, a problem you could maybe do in your head, but I will show the step of dividing by 7 to get y is equal to negative 11. On this fourth example here, the constant is 27, and so what is not shown here is that 27 is positive, so in order to get rid of it, I have to subtract 27. 27 minus 27 is 0. And when I subtract 27 from negative 8, I'm left with negative 35. On the right-hand side, I have negative 5x, and when I divide by negative 5, I have x isolated on the right side, and negative 35 divided by negative 5 is a positive 7. Something I am not so good about showing is substituting back in to make sure the answer is correct. If x is 7, we have 27 minus 5 times 7, which is 35. 27 minus 35 is negative 8. A couple more problems here. Again, on this example, if I want to isolate the variable x, I want to add or subtract a constant, and even though this 10 does not have a positive sign in front of it, we know that it's a positive 10, and so in order to get rid of that, we get a negative 10 or minus 10 from both sides, and we get negative x is 40. but we never want to know what a negative variable equals. So we can divide by -1 and get that x is equal to -40. If I substitute that back in, does 10 minus a -40 give me 50? Yes, it does. I just see a lot of students on this type of problem want to do it mentally, and then they miss it because they forgot a negative sign or they don't show their work. So take a few extra seconds to show your work and make sure that you get it correct. On this last problem, again, in order to isolate the x, I'm going to usually add or subtract a constant. In this case, the constant is 18, and so to get rid of it, I subtracted. 18 minus 18 is 0, and 15 minus 18 is -3. What I'm left with is negative x over 15 is equal to -3. I'm just going to move that negative sign down to the 15 and multiply by -15 so I can cancel it out. And when I multiply -3 by -15, I get a positive 45. So when I plug 45 back in for x, 45 divided by 15 is 3, and 18 minus 3 is 15. Just to review, two-step equations require 2 steps to isolate the variable. Typically, two-step equations follow the same format, not always, but typically the first step is going to be to either add or subtract a constant, and the second step will be to multiply or divide by the coefficient. I hope these extra problems helped you prepare for these 2 tests on the 100 equations unit.